Problem 2 talks about Ben Laberin. It says Ben Laberin, where is it? Ben Laberin works for the South Bookstore during the summer months to help prepare for fall sales. Ben pulls book crate handles with a force of 692 newtons at an angle 36 degrees above the horizontal to accelerate a 112 kilogram crate of books. The coefficient of friction between the crates and the vinyl floor is 0.548. Determine the acceleration experienced by the crate. Suggestion: begin with a free body diagram of Ben Laberin. Ben Laberin here. All right. So I'll just set that up over here with a different color. We'll start off with our purple. So Ben is pulling a crate. So here's a crate of books. Here's a floor. Should be on the floor, not through the floor. And he's pulling at what angle? 36 above the horizontal. So he's pulling, let's use a different color for the pull. He's pulling 36 degrees above the horizontal. That's 36 degrees. Okay, and the force he's using, 692 newtons. 692 newtons. That's the force. Great. What else do we know? We know that the mass of the bookcase, the mass of the bookcase is 112 kilograms. So sig figs, just to make sure we know what those things are. Our sig figs, oh, it's 36.0. So there's 3 sig figs here, 36.0 degrees, 0 degrees. So we've got 3 sig figs. That's what we'll have for our final answer. Right. So it says the coefficient between the crates and the vinyl floor is 0.548. So we assume here that it doesn't really matter if it's static or kinetic. We just have to work with what's given to us. So let's say it's kinetic. It's 0.548. That's mu k. Do we know anything else? No, that's all we know. Okay. Now, we want to do what? What do we want to find? We want to find the acceleration experienced with a crate. To find the acceleration experienced with a crate, we know that there's a force applied here. We want to know what's the acceleration to the crate. Well, at the end, I'll write this up here in a different color. In the end, the only way we can find the acceleration is using Rf equals ma, right? That's the only way we can find that. We know what the mass is. It's right here. It's 112. We don't know what the force is, but I think we can figure it out. The way we can figure it out is by summing all the forces up on this crate. So it said begin drawing with a free body diagram. Let's do that. Let's draw a free body diagram right here. Let's put in the other forces. So we know that there's force due to gravity, Fg. We know that there is a normal force, and we know that there is frictional force. The frictional force is always, I didn't say this before, but frictional force is always opposite the motion. So if you're moving right, it's always going to be against that movement that's left. If you move left, the frictional force is always pointing to the opposite direction, so it'd be pointing right. Right. Okay, so one thing we know is that there's no motion in the vertical direction, so that's good. So in our y direction, the sum of all the forces in the y direction is 0. So we don't need to worry about that. We can just ignore that. But we can find the sum of all the forces in the x direction, and when we do that, we can find the acceleration in the x direction. So we use this formula up here. So let's do that. So the sum of all the forces in the x direction. So what are the forces in the x direction? In the x direction, we've got this. Well, it's not going to be this because there's a diagonal right here. It's going to be this component of this 36 degree force right here. And it's also going to be the friction force. So I can say that it's the x component of this, and we can figure out what that is right away. So let's figure out what that is right away. It's going to be 692 times the cosine of 36.0. All right. Do I have what that is? I don't have what that is. But we'll just leave it like that. Okay, so that's in the x direction. That's this component right here of the 692. But we also have the frictional force, and we don't know what that is yet in the x direction. So how could we ever find the frictional force? Well, if we look over here, oh no, it went away. What happened? How can I get that back? If you look over on this side, well, I have it written down over there. Friction, oh, here it is. Friction equals Fn times mu k. In this case, k is what we're going to be using, mu k. Right? So if we find Fn, and we know this already, we can find the frictional force, which is awesome. So let's find what that is. Let's use a different color here. What should we use? Let's use midnight. All right. So we're looking for Fn. How do we figure out what Fn is? How would you figure out what Fn is? So we do kind of need to know what the forces are in the y direction. Let's use that over here. So let's use y direction over here. So the forces in the y direction, we've got Fg plus, what else do we have here? We have Fn in the y direction, and then we have the y component of this force right here. So it's going to be plus, we'll use 692 sine of 36.0. Okay? Right, and all of this will equal 0 because it's not accelerating up or down, so the whole thing will equal 0. So we still know that it equals 0. I hope that makes sense. So Fg is going to be fairly simple. It's going to be m times g, and we know what that is. Fn, we don't know what that is yet, but we know what this, we could figure out what that is, 692 sine 36.2 degrees. I haven't done any calculations. Notice that I haven't done anything yet. I'm just setting it up for the final calculation. So this Fn is going to be minus mg minus 692 sine of 36. All right, that's my alarm, meaning that we don't have much time. Okay, I have to do this fairly quickly so I can fit it in one video. So this will equal Fn. Okay, so let's see here. So if I know what Fn is, then I can figure out what this frictional force is. So if I multiply all of this out, I'm going to get Fn equals something like 691.85 something. ... Okay, that equals Fn. Now I'm going to take this right here and I'm going to plug it in to this formula right here to get friction. When I do that, my friction force, because all I use here, make another arrow, it's going to look sloppy here. I plug that in, multiply that, and my frictional force is going to be, I think I'm reading this right, 378.59, 378.59, blah, blah, blah. Okay, that's my force in newtons. Now, you have to make a decision here. Is this frictional force going towards, or you just have to assign, is it going to be a positive number or a negative number? Since we're pulling in this direction, I like to the right, I like to say that that's positive, and I like to say that friction is negative. So even if we have a positive number right here, we know that we can make that a negative number because it's opposing the force. So that's just something that you have to think about here. Is this frictional force going to be adding to this force that you're pulling in this direction? No, it's going to be subtracted from it. So in this case, we can either say this is actually in the x direction subtracted, or you can just make this number a negative, and that way you can say plus and it'll be a negative number. But in the x direction, when you take this number, whatever you got for that answer, And then let's say subtract this positive number over here. You should get for x, the force is, what is it? I don't even have it written out. Whatever it is, it's a force in the x direction. And that's this force right here. Okay? So that equals F in the x direction. So F in that x direction equals m, and then the acceleration, F equals ma, praise Newton. We divide both sides by m, so it's going to be Fx divided by m, and that will give you your acceleration. And we know what m is because it's given to us in the problem. Whoa, hello, arrow. So our final answer, whoa, drum roll here, the final answer is acceleration equals 1.61 meters per second squared. Okay, that's all the time I have for now. Good luck.